Alright, as I was saying, let's say that we want every elf to have a nillable reference to some other elf called its friend. Okay. And the friend reference, or the friend variable, is nillable. So when you're doing quick and dirty programming, this is something that you might end up doing. But you also might be interacting with another piece of code which is very polished and doesn't use nillable types very much. And I'm just using this greet method as an example of that. Greet has one parameter, which is an elf, and it is non-nillable. So if I were to try to pass friend into greet, I would get an error. So self greet self.friend. I can't do that. Friend is nillable, and when I pass it into greet, its value might actually be nil. And what would be the point of defining a parameter as non-nillable if you can just pass nil in for it? So basically, the way around this, if for some reason you know that friend is non-nil, the type checker can often figure that out just by looking at the surrounding context. So for example, one way to know whether or not something is nil is to explicitly check it. So if I were to say if self friend is not equal to nil, then great. Alright, now we know that friend is not nil, so I should be able to pass it into great. Alright, so we can see self.friend kind of got promoted to non-nillable inside this if block. And outside, we don't know whether or not the if clause was taken. So if we try to pass friend in for greet, of course we get an error. So that's pretty cool. Another way that we can deduce that certain variables are non-nil is by comparing them to non-nil variables. So here we have self.friend is nillable, but enemy is non-nil. So if we determine that friend is equal to enemy, and I don't know how that makes any sense, but this also tells us that friend is non-nil, and now we're not getting an error in here. So if a nillable instance is equal to a non-nillable instance, then the nillable instance must not be nil. There's only one value